Halloween is right around the corner, and so it is time to break out the glow-in-the-dark filament and print a ghost. A good design for a Halloween ghost includes irregular curves and free-flowing lines blending together. I suppose if I were more of an artist I might want to sculpt that in Blender, but I'm a lot better at mechanical CAD. Fortunately, we can let mathematics intrinsic to FreeCAD do the hard work for us. I'll be using FreeCAD 1.0 Release Candidate 2 and my patched Prusa Slicer 2.7.4 for this video. I will start with the bottom edge of the sheet. Since we need to be free-flowing and curved, an ideal choice would be a B-Spline. The nice thing about B-Splines is that you can draw just about freehand with them and get them to curve any way you like. The difficult thing about the B-Spline is that you have all of these loose control points wanting to go every which way. That makes it hard to adjust the size or to keep the curve within bounds. But there is a way. So I'll start with a sketch on the XY plane. Draw two concentric circles constrained to the origin. The B-Spline is going to be drawn in between them. I want the approximate radius of the bottom edge to be 30 millimeters. So constrain the inner circle to 25 millimeters and the outer circle to 35 millimeters, giving us 30 millimeters on the average. Now select the B-Spline tool and make the starting point fixed on the Y-axis. Zigzag along the circles, fixing each of the control points to be on the inner and outer circles alternately. Just work all the way around the circle. Don't worry too much about the individual placement. You can always slide the control points around a little bit later. Just make sure that when you get back to the end, make the end point of the B-Spline coincident with the start point. That actually looks pretty good. Since we don't want the guide circles to actually be part of the solid, select them both now and toggle them to construction geometry. Close the sketch. That's a good start. The objective is to create a loft that rises up and eventually closes over the top to form the old sheet with eye holes costume. This will require a little bit of additional guidance to get anything like with the shape we want. Select the sketch and create a sub-object shape binder. To get a flare at the bottom, offset the shape binder to -9 millimeters. Going through the various options for how the offset is formed, there's not much difference in the look in this case. Since it all looks the same, just leave that for now. In the data pane, open the placement and go to position.z and set it to 25 millimeters. Select the shape binder and create a sketch. Use plane face as the attachment mode. Draw a circle completely inside the shape binder to be the next profile of the loft. This will guide the eventual solid to taking a more circular form so that it can close neatly over the top. Because of the way that the loft curves the surfaces to match profiles, it won't result in having an awkward cylinder at the top. It'll flow quite nicely. In the data pane for the new sketch, go to the attachment position Z and set that to 25 millimeters. Select that sketch and create a new sketch attached in the Object XY mode. Create a small circle inside. Close the sketch. In the data pane, set attachment.z to be 10 millimeters. Keeping it closer to the previous sketch gives the surface a more acute curve at the top so that it closes smoothly over as a dome. Create the loft and add the profiles in order, starting with the first sketch, then the binder, sketch 1, and sketch 2. Check Create Solid and OK. Looking at the loft, we have an unfortunate flat spot at the top. Edit the sketch and reduce the size of the circle. That's looking better, but it's still a little bit too flat. Make the circle even smaller. That's looking a lot better. That little bit of flatness at the top will not even be noticeable when rendered in a solid form. Now to make a cutout for the eyes. Start with a sketch on the XZ plane. Just to get a feel for the positioning, place a line on the x-axis that extends beyond the edges of the ghost in both directions. Close that sketch and go to Placement, Position, Z. Start at 40 millimeters. It needs to be a little higher. We just need a good center line for the eyes. It's more aesthetics than science. 43 millimeters looks good. Reopen the sketch. Set the cross-section view so we can see what we're sketching. Select the ellipse on the center point tool. Place an ellipse roughly where one of the eyes should be. Pull out the minor axis along the x-axis a bit, and pull the major axis a little bit taller along the y. Just move that inward a little bit to make it more eccentric. I just want to get it roughed in at the moment. I move the minor axis guide point a bit, and I see the ellipse is free to rotate. I want the minor axis to be affixed to the x-axis. So set a point on object constraint. You may want your eyes to actually be at an angle. If so, you can either use the angle constraint or leave it unconstrained. It's completely a matter of artistic choice. Now create an eye on the other side. Zoom in a little so we can see what we're doing. Now I'll constrain the major axis of each eye to be the same, and then the minor axes. You're welcome to make the eyes different sizes for your ghost if you want. Now make the centers of the ellipses symmetrical with the origin. Move them a little closer together and that looks pretty good. Close the sketch. Before we cut out the eyes, we need to make the ghost body hollow. Otherwise, scaling the hollow core will cause distortion in the eye holes. Select the loft and make a draft clone. Press GR to get rid of the draft plane. As you can see, the clone exactly fills the space of the ghost body. Select the clone, and in the data pane set scale X and Y to 0.9. To see if that looks right, select the loft and in the view pane, set the transparency to 50%. Select the clone, and we can get some idea of what the walls are going to look like. The clone is going to be good for hollowing out the lower part of the ghost body, but we need a little more control over the top. Create a primitive plane large enough to completely cut through the clone. Right-click the plane, select Transform and slide it into place on the XY plane. Now switch to a front view, transform the plane again. Lift it up to just a little bit below the eyes. Select the clone, select the plane, and go to Part, Split, Slice Apart. Open up the exploded slice. It looks like Slice.0 is the one to keep, so hide Slice 1 as a reminder that that's not the one we want. Hide the loft. Bring the view around to the top, and select the top face of Slice 0. Create a sketch on the plane face. Create a circle centered on the origin. Bring it out so that it sits at the top of the slice. Extrude it to 10 millimeters as a rough-in. The cylindrical cutout needs to accommodate a black insert that will completely cover the eyes. Select the extrude, Go into the data pane and increase the length forward until it ends up a little bit above the eyes. At the same time, it cannot protrude through the surface of the ghost body. So make the loft visible again. It's quite apparent that we're going to have a bit of a problem with this. A combination of reducing the radius of the cylinder and reducing its height just a bit will solve this. I'll start by reducing the radius a bit. Looking again shows that we're getting in the neighborhood of right, but it's still not enough. Reduce the height of the extrusion to 17 millimeters. That actually looks pretty good. The number of entities we're keeping track of is increasing quickly. Renaming a few things will make it easier. Rename Sketch 3 to iSketch. To make the hollowed out core, select Slice 0 from the exploded slice and the extrude we just made and fuse. I'll rename that fusion to core. Select the loft, select the core, and cut. Now the ghost is hollow. I'll just rotate it around a little bit and have a look inside. Make sure it's what we want. It does appear to be good. Now to get back to the eyes. As you can see, the eye sketch is situated in the middle of the ghost body, which is fine. Select it and extrude to 80 millimeters or so to make sure that it protrudes completely through the front. Clearly 80 millimeters was quite enough, so select the ghost, select the extrude, and cut. I'm going to set the transparency back to 0 just to make it a little easier to visualize. I've renamed Cut 001 between the hollowed out ghost and the eye tool to Ghost just to keep things straight. It can sometimes be very useful to look at your designs in a slicer. Select the ghost and export as ghost.step. Take the defaults. Load up Prusa Slicer and import the step file. It actually looks pretty good. Let's look with the sliced preview. We have support on the build plate, and I've selected organic supports. Look down through the slices. I see we have some organic supports on the top of the eye holes. That's not surprising, but we seem to have an awful lot of organic supports all around the inside of the body. Moving down further, this is exactly at the point where the core transitions from slice 0 to a cylindrical extrusion. That's left a fair bit of material that has to be supported just outside of the cylinder, but it can't be bridged because there's a giant hole in the middle. That's hardly the end of the world, but even with the organic supports, it represents extra time to print and extra materials, and there's no need for it. Instead, go back into FreeCAD and create a 0.2 millimeter sacrificial layer closing off the bottom of the cylinder, so the slicer can simply bridge across the top. When the print is complete, I can use a modeling knife and perhaps a sanding drum on a rotary tool to cut away the thin sacrificial layer. Select the opening to the cylindrical cutout. Create a binder and extrude that binder to 0.2 millimeters, the layer height I intend to print at. Select the new extrusion, select the ghost, and fuse. Now select the fusion and re-export it as ghost.step. Accept the defaults as usual. Back to Prusa Slicer. For some reason, sometimes the slicer will simply reload the step file. In other cases, it refuses. This is one of those, probably because the top-level object is named Fusion rather than Ghost. So I'll just delete it and reload the step file. Back over to the slice view, conveniently right where it left off. It shows that we are now bridging across the entire body rather than relying on organic supports. The supports for the tops of the eyes have moved to the outside, and we have just a little bit of support down at the base where we're flaring inward sharply. That's fine. Step through the model a little bit to get some idea of how it's going to go. You can see here where the thickness of the body is being laid over the bridge along with the perimeter of the hollow cylinder inside. It looks like the eye holes will form pretty cleanly with only a little contact with the organic supports at the top. The infill looks pretty reasonable. The print is going to take about 2.5 hours on the venerable Ender 3. The design is looking really good, but you can see the inside of the print through the eye holes. While in many cases that might not matter much, here the intention is to print it in glow-in-the-dark filament. There's reason to be concerned that if the light is shining through the eye holes as well, the eyes really won't be visible at all, ruining the effect. To avoid that, we need a black insert that can slide into the cylindrical space behind the eyes so that none of the glowing effect will shine out. In order to get the size right, I'll make that insert in reference to the sketch that makes the cylinder and the core. To avoid confusion, hide away the ghost and any extraneous sketches that could be mistaken for the core cylinder sketch. Now select the core cylinder sketch and create a new sketch. Attachment mode concentric. We need 2 circles to specify the inner and outer wall of the shade. Bring in the circle that formed the cylindrical extrusion as external geometry. Select the external geometry circle and the outer circle of the sketch. It may be easier to select the external circle from the geometry listing in the left-hand panel. Now click the multi-dimension tool and select an offset. 0.2 mm should be good, depending on your printer and how tightly you want it to fit. Notably, when cleaning up my print later, there was a bit of persistent burr that kept it from fitting properly. I ended up solving that by cutting through the back of the ring to allow me to compress it into place. That worked just fine, so this really isn't that tricky. Now select the inner circle and the outer circle and set an offset of 1 mm. Close the sketch. Select the newly created sketch and extrude it to 10 mm to rough it in. Select the extrusion and in the data pane set a formula of the length forward to extrusion.lengthforward minus 1 mm. Extrusion is the actual name of the cylindrical extrusion that formed the core, not just a description. That gives us a little tolerance to deal with possible sag in the bridge over the top of the core cylinder. Select that newly created cylinder and in the view pane, in Shape Appearance, set it to black to help visualize the final result. Now make the ghost visible again. Zooming in, it looks like the very top of the eye holes might not be completely covered. It probably wouldn't make much difference in the actual physical assembly. The black cylinder would probably fit up far enough to cover that over. But just to be absolutely sure, select the eye sketch and go into Placement Position.Z and move it down from 43 mm to 42.75 mm. It's not going to make much difference to the appearance of the model, but it does bring the top of the eye holes down just far enough to be safely backed by the black cylinder. Now to slice and print. Select Extrude 003 and export as Ghost Eyeshade.step. There's not really much to say about printing it. It's just a simple small ring. I printed mine in black PLA mostly because I had a lot of it left over and it's not going to expose to a lot of heat. Just a small reminder, if you're using my patched Prusa slicer, when it's imported it will be floating well over the top of the print bed, just because objects in the step file maintain their offset from the origin that they have in CAD. Amusingly, and to the slicer's credit, it will actually build supports to print it at that height. Just click the icon to the right of the object to drop it down onto the bed. I would print it with a brim since it's just a small cylinder with 1 mm walls. There's not much adhesion to be had otherwise. As for the ghost itself, I'm using CC3D glow-in-the-dark green PETG filament. So I just picked filament settings appropriate to PETG. I should note that glow-in-the-dark filament is extremely abrasive and you will need a hardened nozzle to print it. The substance that glows in the dark is in the form of small particles, and apparently those particles are harder than brass but softer than hardened steel. If you attempt to print with a brass nozzle, it will probably erode away before the print is even finished. I'm using a hardened steel nozzle on my printer and found that I need to print just a little bit hotter than I would with a brass nozzle to make it work. The filament manufacturer recommends 240 degrees plus or minus 5 degrees, but I got excellent results printing the first layer at 255 degrees and the rest at 250. Bed heated to 70. It's worth noting that those temperatures are just a little bit too hot for a PTFE lined heat break. I know Capricorn suggests you can go hotter, but honestly even 240 degrees Celsius is pushing it for any PTFE. The Bowden tube that comes with the Ender 3 probably shouldn't be used any hotter than 210. A good bimetal heat break is inexpensive, easy to install, trouble-free to use, and will let you confidently print much hotter when you need to. Even with the Stockler Mister, you can print a nice PA6 nylon at 275. The printing itself was uneventful other than being able to see it unusually well because it actually glowed. But the results were quite nice. As it turned out, 0.2 millimeters was not enough clearance to get the black cylinder behind the eyes, but all I had to do is take the cutters that came with the printer and cut through the back of the ring. That allowed me to push it a little smaller and slide it in. I believe it'll hold under its own force, but if necessary, a drop of glue will take care of it. So if you need something other than candy to hand out for Halloween, or need a few extra decorations, or just wanted an excuse to use glow-in-the-dark filament, this is the time. Happy Halloween, everybody. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.